Okay, good evening, students. So I'm back once again with one of the problems in mechanics, which I find many of the students make mistakes in inclined plane problems. Now let us begin. A ball is released from the top of an inclined plane of height 4 meters. Let me draw an inclined plane. Just a moment. I'll keep it here. Okay. A ball is released from the top of an inclined plane. You know what is an inclined plane, right? Inclined plane looks like an incline. Very simple. Okay. This is an inclined plane. Now, in physics, whenever you want to solve some problems, you need to draw a diagram. Without drawing a diagram, as much as possible, 99.99% of the time, never attempt any problem. It might take another 10 seconds extra, but it will always help you out. Okay. So once you are conversant, even you are good enough to understand everything mentally, then you can proceed without drawing a diagram. Now we have drawn an inclined plane. As you know, in an inclined plane, let us label it like A, B, and C. And then this will also have some angle theta here. Okay. Now, a ball is released from top of an inclined plane, at the top of an inclined plane. Here we are releasing it. Then of height 4 meters, which is the height here. This is my height. This is my height. 4 meters. And then length of the plane is 5 meters, which means starting from here until here, it is 5 meters. This is also given. Then what will be the speed of the ball when it reaches the ground? When it reaches this point, okay, what is the speed? Okay, so towards it. Now, most of the students, what they do is, they already learned equations of motion. So first thing they do is, okay, anyway, distance is given to you 5 meters. They will substitute it. S is equal to 5 meters. U, initial velocity. Anyway, they know. You put U equal to 0. G value is 10. Substitute it and you get the answer is 100. Or V is equal to 10 meters per second. Okay, this answer is incorrect. There's one more method which students do, or one more solution they give you. The solution is that they'll write something like V square is equal to U square, which is 0, plus 2 times 10 times. Instead of taking S equal to 5 meters, they take it as 4 meters. This side is already given, right? So therefore, they get the answer as 80. And this means you will get the answer V should be equal to a square root of 80. Okay. So what is the value of square root of 80? 81 is 9. It's nearly 9 meters. 9 meters per second. This is what they get. This is also incorrect. Now let us first understand why these two solutions are incorrect. Why shouldn't I use this? See, S is correct, G is correct, 2 is correct, everything is correct. What can go wrong? The first principle that can go wrong here, or what would have gone wrong here, is that we will investigate on the value of U. Okay? Why should U be taken as 0 here? See, I have taken U equal to 0. Why? Look at this. A ball is released from the top, which means what? It started from the rest position. So definitely there is no doubt, okay, that we have taken the right parameter. Definitely the value of U equal to 0. See, whenever we get a wrong answer, okay, first thing we should ask is, can I use this equation? Okay, that's the question I need to ask. Can I use this equation? Of course, I can use the equation. Why only this equation? There are several other equations, right? S equal to ut plus half at square we have. Then we have, what else we have? V equal to u plus at we have. And then we have S equal to V into T you have, right? 3 equations you have. I have not used anything. I use only this one. What is the reason? Okay. So the reason here is that, see what is given over here. Okay, whenever a problem is given like this, write down the parameters here itself. U equal to 0 here. And there's some height is given, S1 is given to you. Then the length of the plane, another S2 is given to you. What is the speed of the ball? Speed of the ball, V is to be found out when it reaches the ground. See, I have divided the problem already into several parts. Okay, so towards it, if I want to use these equations, I need an important parameter here. What is it? Time taken. The time is not given to me. So as a result of it, all these 3 equations cannot be used or will not be used. Right? Now, the next question is, see, U is equal to given, but I do not know whether to use this height or this height. And lastly, just a moment. That's an important call I am getting. Okay, I'm back. Right. Okay, so I was saying that u is given here. I am going to use this equation. U is given to you. Yes, there are two s given. Which s should be considered? I do not know. Let us see that. Okay, and then G. Now I have not spoken anything about G. Now G, what is G? Acceleration due to gravity. Why do we get this? Because of the earth. If the particle is on earth, you get G here, right? Now imagine if this inclined plane was not there and the ball was supposed to be dropped here, then what would have happened? The ball would have come down directly like this. Now, if it comes down, what is the acceleration? The value of acceleration is G once again. But now, when you have the particle on the plane and the ball is now moving like this, will it be the same G? Obviously, no. Why no? Because what is this G? Why do you get this G? Because this is our Mother Earth. What does it do? It tries to pull the particles like this. Now, who pulls it here? Is the earth saying, hey, you are like this, I'm going to pull it like that? Aisa खींचूंगा मैं? Not possible, right? So then why should the particle come? When an object has to come down, there should be a force. If there is no force, the object will not come down. Which rule? Newton's first law, inertia rule, right? Inertia says, every object is very lazy. This object, if you don't disturb it, will just stay there. If there was no gravity, you take the inclined plane and the particle to the space, you keep it on top of it, it will just stay there only. It won't move. Why? Because gravity is not there. Now, agreed, Baba. Now you see, gravity has to pull it down like this. But why is it moving like this? Who is disturbing it here? That's the question we need to ask. So, now what we do is gravity is a vector. Okay. So when you have a vector which is directed downwards like this, and then this is my inclined plane, and this is acting on the object over here. This is acting on the object here. I have written a ball, I have written a rectangle here. Doesn't matter. Okay, for a change, I need this. Later on, we will see. Okay. So therefore, if this is my angle theta, this is my angle theta. Now, see, this is a right angle triangle. See, this line, okay, along with this vector, and this one is a right angle triangle. So what should this angle be? If this is 90, let me understand that this value is some alpha. I do not know what is that angle. Okay, let me go from very basic, right? So therefore, in a triangle, we know that alpha plus theta plus 90 is equal to 180. What is this 180? Why it comes? Reason is because this is nothing but sum of the angles in a triangle, right? So therefore, alpha plus theta is equal to 180 minus 90, which is 90 degrees. Or alpha, which is an unknown thing, is nothing but 90 minus theta, right? So this value of alpha is 90 minus theta. Now, what do we need over here? Now, let us write down the forces acting on the particle, on the ball. The first force, since it's resting on the plane, there is a normal force acting like this, right? And then the second force is nothing but mg force acting downward like this. And then now what we do is, let me resolve this mg into two parts. What is resolving? Resolving is nothing but splitting a vector into two parts along the x-axis and along the y-axis. Now, which is the x-axis? Usually we consider this as your x-axis, right? This should have been your x-axis. But to make things more easier, what I do is, I will consider this as my x-axis. Along the plane, I'll consider x-axis. If this is x-axis, a line drawn perpendicular to this should be your y-axis. See, this should be your y-axis. See, this is my x-axis, this is my y-axis. Okay. So if this is my y-axis, I'll pull this one backward like this. Pull it backward like this. Now you see, this angle is 90 degrees, correct? See, this angle, if this angle is 90, this angle should have been 90. It's the same line over here. It's exactly perpendicular here. If this angle is 90, let me call this angle as some y over here. Can I write y plus alpha is equal to 90. Can I write like that? Y plus alpha equal to 90. See, this angle y, this angle alpha equal to 90, or your y value is equal to 90 minus alpha. Am I right? Okay. So work it out. Y equal to 90 minus alpha. But we already know alpha is equal to 90 minus theta. Let us substitute that also. क्या कर रहा है यार, इतना मैथमेटिक्स है, 90 minus of 90 minus theta, which should now be equal to 90 minus 90 plus theta. You know, this addition and subtraction will never leave us. From the third standard I have been studying, it never leaves me. So this value is equal to theta itself, which means this y I will replace it by theta. Okay. So now you see, this is mg vector. This side it's alpha angle, this side it's angle theta. I'll resolve this mg, I'll split this mg to find out the contribution of mg along this direction, which should now be equal to mg cos alpha, right? Similarly, along this direction, it should be mg sin theta, right? Now, based on this, now what is the acceleration along this direction? This is the net force acting here. So, if F is equal to mg cos alpha is the net force acting here, I'll write ma is equal to mg cos alpha, or a is equal to g cos alpha. I can write a equal to g cos alpha. Now, once again, now a equal to g cos alpha. Now, what did we do? We assumed that the value of a here is just g. This was the mistake that we did. Are you getting me? Did you realize where we made a mistake? The mistake the student makes is that he assumes that the value of g is the same whether it goes along an inclined plane, or it falls vertically, or it goes horizontally, whatever it is. Okay, that is a mistake. Now, so towards it, a equal to g cos alpha. Now what we need to do is, let us substitute it. Now with the same equation, v square equal to 0 plus 2 into, what is the value of g? 10 cos alpha. What is the value of cos alpha? That is the headache now. Okay, we'll write cos alpha only first. Cos alpha into s. Which s should I am going to take? See, this g cos alpha is the acceleration of the particle throughout the inclined plane, throughout this direction. So this should be 5. I'll write like this. Now the question is, अरे यार आपने alpha नहीं दिया है. You have not given me the value of alpha. How do I determine what is it? Correct? Yes, you are right. Okay, let me write down the plane here. Let me write down the plane here. This value is theta. This value is 90. See, alpha is this angle. This angle is alpha. And what is the length of the plane? 5 units. See, 5 units given here. Height of the plane, 4 units. Now, by Pythagoras theorem, you find out what is this length. This length should be 3 units over here. You can find out 3 square plus 4 square equal to 5 square. How do I know? Many times we have done this, right? From our 7th standard, when we learned Pythagoras theorem, okay, every teacher used to teach, Pythagoras theorem, then 3 square plus 4 square equal to 5 square. 9 plus 16 equal to 20. So, we have got this. Now, from this triangle, can you tell me what is sin alpha? Sin alpha is equal to opposite by hypotenuse, which should be equal to 3 by 5. Dekho, aa gaya hum. And then, what do you need? Oh my God, I need cos alpha here. What is cos alpha? Cos alpha is equal to 4 by 5. See, adjacent by hypotenuse. Let me substitute it. This should be 0 plus 2 into 10 into 4 by 5 into 5. And this 5 and this 5 goes away. So 2 into 4 into 10 will be equal to 80. Right? So 80, what is it? Meter per second. And thus we get this as equal to v square equal to, v should be equal to square root of 80. Right? So which is nearly equal to 9 meter per second. But yeah, we have got the same thing here also. Then what is wrong? Why did we consider this wrong? To get an answer for this, you should watch my next video. Okay. By the meantime, this should be there, right? Hey, I did like this, but the sir gave me wrong. Why? See, I've got the same answer once again. What was wrong here? You would have given me correctly, right? What was the wrong thing over here? Okay, in order to get this answer correctly, you should watch my next video to understand this. Okay, so for now, let me stop here. The video has exceeded more than 10 minutes. So next video, we will see this. Thank you, friends, for watching my video. Like, comment, and subscribe my channel for further updates. Thank you.